Hey guys, welcome to another video on how to use your calculator in physics. Today I'm going to be showing you how to use a different style of calculator, which is this one that I've got here on my screen. Now I'm sure that some of you have got this style of calculator, so let's learn how to use this one. So the first thing that happens is when you turn your calculator on, you get this screen here, okay? And you can select all these different modes, but for physics we want number one, calculate. So you can either just put the grey box over that one and press OK, or you can press the number one on the keypad. Both of them will take this screen. So this is the screen where you want to start. Now you'll notice that on this calculator, there's no equals button, okay? That's because we've got this button down here, execute. That's now our equals button. So if we want to do a sum like 3 plus 8, we press execute, and that gives us our answer here. So instead of pressing equals, we're now pressing execute, okay? The final thing that might be useful to you is that if you want to convert between a fraction and a decimal, so for example, if I do 5 divided by 6, I get this fraction here, which for maths might be fine, but for physics, we like to give our numbers as decimals rather than fractions. So we're going to use this button down here, this format button, okay? And that will turn it from a fraction into a decimal for me. So let's show you how to use this calculator with some examples. We're going to start with my favourite equation, which is Newton's second law, okay? And Newton's second law, we all know it's F is equal to m times a. So that's force is equal to mass times by the acceleration. So I'm going to imagine that my force is 12 newtons, my mass is 18 kilograms, and I want to find what my acceleration is, okay? So I'm going to start by substituting my numbers into my equation. So I've got 12 is equal to 18 times by a. Right, I want to find the acceleration, so I want this equation to read like a equals, okay? So I need to get rid of this times 18, and the opposite of a times 18 is a divide by 18. So I'm going to divide both sides by 18. So I've got 12 divided by 18 equals a. Right, let's grab out my calculator because I can't do that one in my head. So I'm going to use the fraction button, which is here. It used to be over here somewhere. Now it's here, okay? I'm going to put the 12 in the top, and then instead of using this arrow here, I'm going to use the down arrow divided by 18, okay? And I'm going to press execute. That's now my equals button. So the acceleration is 2/3. But as we all know, we don't use fractions in physics. We want to give our answer in a decimal. So I'm going to use this button down here, which says format. Okay, I'm going to press the format button down here, and it's going to turn it into a decimal for me. So this is 0.6666666666667. So it's 0.6 recurring, right? But I don't use recurring decimals in physics either. So I'm going to write this number to 2 decimal places, okay? Because that'll be the first decimal place, this will be the second decimal place here. This number here is a 6. It's a number that's 5 or bigger, so I'm going to round up. So this is going to be acceleration is equal to 0.67 meters per second squared. So that's how we use our format button. Right, let's have a look now using the answer button because that's also changed. So we're going to look at the equation for elastic potential energy, which is a half kx squared, where k is the spring constant and x is the extension. So we're going to imagine that we're actually looking for the extension this time. The elastic potential energy stored is going to be 40 joules. The spring constant is going to be 12 newtons per meter. And I'm looking for the extension, okay? So the first thing I'm going to do is I'm going to substitute all my numbers into my equation. So I've got 40 is equal to a half times 12 times by x squared. And what I'm looking for is this x squared, okay? So this all looks quite complicated to start with, but let's break it down. So I'm going to start by just doing this first bit here, just to simplify everything. I'm going to start by just doing a half multiplied by 12, okay? So that would be 6. So I can rewrite my equation as 40 is equal to 6 times by x squared, okay? Now I'm just going to look for the x squared. So because it's this times by 6, I need to divide both sides by 6. So 40 divided by 6 equals x squared. Now, I always do equations like this in 2 parts. I'll show you the quicker way, and then I'm going to tell you why I don't do it, okay? So I'm always going to start by working out what x squared is first. I'll do the same thing if it's kinetic energy, anything like that. Okay, anything with a squared in it. I'm always going to work out just what the value squared is first. I'm going to use my fraction button. 40 divided by 6. Execute, and I've got an answer of 6.67. Okay, 6.6 recurring, 6.67. Perfect. Okay, so x squared is 6.67. Right. Obviously, I'm not looking for x squared. I'm looking for x. So I need to find the square root. Okay. So to do that, I can grab up my calculator. Now, I'm going to show you something really good here. I'm going to press the square root button straight away. Then what I want the number that I calculated previously to go into that square root, right? So I can just press this answer button here. And what that does is it stored the number, like the last number that you calculated, and we can just put it straight back in. So it's a little shortcut to getting this number. Press execute again. And woof, what is that? 2.58. Lovely. I'm not going to go to 59, you see, because it's 2.581, right? This is a 1. This number is less than 5, so I'm going to round down. So my answer for x would be 2.58 meters. Lovely. Right. Another way of doing this step here is instead of working at x squared, then just going straight down to x, you could just do x is equal to the square root of 40 over 6, okay? But you're slightly more likely to make a mistake using your calculator if you do it like that, okay? Because what we've got is you have to make sure that you press the square root, then the fraction button if you're going to do that. And you've got to make sure that you do it that way specifically, because otherwise, so this gives me the same answer I've got previously. Happy days, perfect. But if you accidentally put your numbers in the wrong way around, so you do the fraction button, then press the square root, can you see it just does the square root of the bit on the top? So then if I did 40 divided by 6 for that, I've made a mistake and I've got completely the wrong answer, okay? So I think that doing this method where you work out what x squared is first and then do square root answer, I think that that method is the safest, okay? Because otherwise you might make this mistake where you only get your square root on the top. Right, let's talk powers of 10 then, because using standard form in your calculator is so powerful. So we're going to do circuits because I love circuits. So we're going to use V is equal to IR, okay? V is 30 millivolts. I is going to be 600 microamps. And I want to know what R is, okay? So I'm going to use my standard form conversions here because I think that they are really useful, okay? So milli is times 10 to the minus 3. Micro is times 10 to the minus 6. So I'm going to start by putting my numbers into my equation, but I'm going to put them in standard form. So they're pre-converted for me so I don't forget to convert my units because I need V potential difference to be in volts and I need current to be in amps, not in microamps. So it's going to be 30. And then where it says M for milli, I'm going to replace it with times 10 to the minus 3 is equal to I for current. So it's 600. Where it says micro, I'm going to replace it with times 10 to the minus 6. Times by resistance, just there. Okay, right, I want to get resistance, so I'm going to need to divide both sides by 600 times 10 to the minus 6. So 30 times 10 to the minus 3 divided by 600 times 10 to the minus 6 would give me resistance. Right, now let's get out my calculator. So what I've got is I need to put this equation into my calculator. So I'm going to use the fraction button because I think it makes everything much tidier than using the divide symbol. You can use the divide symbol if you want, but I think using the fraction button is just so much tidier. So I'm going to do 30 and then times 10 to the, and you can see this one also puts it into the little power up there for me, okay? The previous calculator didn't do that. This one does it for me. Minus 3. Right, then I need to make sure that I come out of that to go into this bottom part of the fraction. Okay, I need to make sure I use the arrows to come out. I'm going to put 600 times 10 to the minus 6 in there. And then I'm going to press my execute button. And there we go. My answer is 50. So my answer would be 50 ohms. Okay, guys, the final thing that I want to show you is how to get your calculator to do your standard form for you. So sometimes you get an answer that's got loads of zeros on it, and as you're writing that down onto your answer paper, you might miss a zero, and you're going to miss a mark. So actually, if you get a really big number or a really small number, sometimes writing your answer in standard form is just easier because it guarantees you're not going to miss a zero, you're not going to miss out on a mark. So let me show you what I mean. So we're going to use the wave equation, okay, which is V is equal to F times lambda, okay? So wave speed is equal to frequency multiplied by wavelength, okay? Now, in this question, my wave speed is going to be 3 times 10 to the 8, or 300 million meters per second, because that's the speed of light. I'm looking for the frequency, and my wavelength is going to be 0.6 meters, okay? So I'm looking for the frequency of this wave. So 3 times 10 to the 8 is equal to frequency multiplied by 0.6. I've just substituted my numbers into the equation. I need to get frequency on its own, so I'm going to divide both sides by 0.6 to get frequency. Okay, right, let's get my calculator out. So I'm going to use the fraction button on the calculator. So 3 times 10 to the 8. And then I'm going to divide it by 0.6. And I'm going to press execute here, okay? And I get this big old number with a whole bunch of zeros on it, right? Now, as I'm writing that onto my exam paper, I might miss off a zero. The zeros are really important because it shows the examiner I know what I'm doing. Because maybe even earlier in this question, I might have had to do like a conversion from like meters, for like kilometers into meters, or from millimeters into meters, or something like that. So getting the right number of zeros shows the examiner I know what I'm doing. So what I'm going to do is I'm going to press this arrow here, which is shift, okay? A bit like you get on a keyboard on a laptop, is this shift button here. I'm going to press shift, and I'm going to press format. And I can go down using the arrows and click standard form here, okay? So I'm going to press OK, or you can just press the number 4. Doesn't matter which one you do. Press OK, and you can see that my calculator's turned into standard form for me. So I could write it like this as my answer. So I could write, instead of all those zeros, I can just write 5 times 10 to the 8 hertz. And there you go. I really, really hope you have found this video on how to use your calculator useful. I really hope it managed to help you. And don't forget that there's loads of questions, loads of extra resources on my resources. So go and check those out. I'll see you there. Take care, guys. Bye.